All right, guys, test 6 review. Here we go. Domain is first. When we talk about domain, most time it's all real numbers. And on number 1, that's exactly what it is, just all reals. I'll let you just go away with that right there if you want to. You could also go negative infinity, positive infinity. The 2 times it is not just all reals is when you have a fraction with an x in the denominator or a radical like 2 and 3. So number 2, where does domain there? 2 ways you can write this. Obviously, x cannot be negative 7 or 5. So you can say all x such that x is not negative 7 or 5. Or you could also, this is a little longer way to go, but you could say negative infinity to negative 7, parentheses with the negative 7 and the 5 because it can include those two, and then 5 to infinity. So just like that, probably that first way is a lot quicker, but it's up to you. Number 3, x squared minus 16. If it's a radical, it must be greater than or equal to 0. You cannot have a negative sign inside a square root. So I get that right there. I'm going to go ahead and factor this. X plus 4, x minus 4. It's the difference of squares. This is where we drew our sign graph to figure out where things are going to be greater than 0. Plug in 100 like we always did. There and there. That's going to be a positive and a positive. So that means it's plus, minus, plus. And again, I'm looking for where it's positive. So my domain is going to be anything less than negative 4. And also anything bigger than 4. And those should have been brackets, by the way. So I'm going to change those two to brackets because it was equal to, greater than or equal to 0. Because a radical can equal 0, it just can't be negative. Well, you got 3 graphs here. And I need you to show me your XY table when you draw these things. Like you should know the general shape. This one obviously is a parabola because it's got an x squared. And I'll usually plug in points that are close to what that parentheses is. So I'm going to start my XY table here. And I'm going to go, let's say I plug in negative 4, I get negative 5. If I plug in, let's see, 1, that's going to be huge. I'm playing something a little smaller than that. Let's go to negative 3. If I plug in negative 3, that's going to be 1 squared minus 5 is negative 4. Keep plugging negatives, maybe a negative 5. Plug in negative 5, also going to get negative 4. That may be enough right there. So let's see, negative 4, negative 5, 1, 2, 3, 4, 1, 2, 3, 4. Sorry, I'm counting out loud. Negative 3, 1, 2, 3, 1, 2, 3, 4, and also negative 5, negative 4, which would be like right there. So that's pretty much enough to draw the general shape of that parabola. Next we have a root graph. Now, if it's an even root, the graph's going to do this general shape. So I know it's looking like that. If it is an odd root, it's going to be half a parabola that way, and then also half a parabola that way. So find your x-bar table, see where it's stationed here, and let's see. I'm going to plug in 2 for the x because that's going to make that just become 0 inside, and I will get 3. Also, be smart here what numbers you plug in. Like I'm going to plug in numbers that actually have a square root to make it a little bit easier for me. So I'm going to plug in 3 for x. Because when I do that, 3 minus 2 is 1. The square root of 1 is 1. 1 plus 3 is 4. Let's get one more point here. I'm going to go with 6. Because if I plug 6 in there, 6 minus 2 is 4. 4 has a square root, which is 2. 2 plus 3 is 5. So let's find those 2, 3. Right there, 3, 4. And then 6, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So that graph's going to look just like that. Remember, you kind of, if I start plugging in something less like if I plug in 1 right there, I'll get a negative inside, which I can't do it. That's why I knew that 2 was the first point in that graph. Number 6, piecewise. Remember how we talked about doing this week? The best way to go is take this number right there and plug it in. Negative 1 plus 2 is 1, so I'd go to negative 1, 1, which is right here. And now because it says less than negative 1, I'm going to go to the left. I'm going to plug in a negative 2. If I plug in a negative 2 in there, negative 2 plus 2 is 0. Now, one thing I know, that's a line. It's linear, so I'm going to go graph that line just like that. It's going to the left. And then let's go to the second graph. I'm also plugging in negative 1 here, plugging in negative 1 squared, which is also a positive 1. I should have an empty circle, but there's already a filled-in circle there, so I'm not going to worry about that. It says greater than negative 1, so I'm going to go to the right, so I'm going to plug in a 0. 0 squared is 0. Keep going. Plug in a positive 1. 1 squared is 1. You can kind of see what's happening here. Plug in 2. If we plug in 2, you get 4. 1, 2, 3, 4. So the parabola is going to be half of a parabola going just like that. It's a cool looking graph. Let's keep going. Number 7, vertical line test. These should be the 2 easiest ones on your whole entire test. Tomorrow, vertical line test. If I draw a vertical line right through there, obviously it's the graph more than once. That is not a function. But no. The second one, no matter where I draw a vertical line here, it looks good, so that is a function. I'm gonna say yes. Number 9, determine whether the equation defines y as a function of x. And all I'm gonna do here is I'm gonna plug in a few x's and see how many y's I get. Let's do this. Another great way to do this, smart thing to do, is get the y isolated. So I'm gonna get the y over here. I have 3x squared plus 4. So I would plug in a couple points. Like if I plug in, let's say I plug in 1 for x. If I plug in 1 for x, I get 7 for y. And the key thing is there, that's the only thing I get for y. It's just 7. If I plug in a 0, I get 4. And again, that's the only thing I get. Let's try a negative just to make sure. If I plug in a -1, I'm also going to get 7, which even though the y's are the same, it doesn't matter. Every x, I'm getting 1 y. That's a yes, because every x has exactly 1 y. All right, next one, simplify this complex fraction. Multiply the whole top and the whole bottom by the LCD, which is 3x. The denominator is easier. X times 3x is 3x squared. 3 times 3x is 9x. There's your denominator. The numerator, when I take this first term, the x's are going to cancel. That leaves 2 times 3, which is 6. The second term, the 3's cancel. That leaves a 1 times x, which is x. Should be a minus sign there. Not exactly sure why I put a plus. Okay, now, technically, I could, if I wanted to, I could factor the denominator. I could take out a 3x, and that would leave an x plus 3. But because it doesn't cancel anyway, either one of those answers are okay. If you put this as an answer, you're good. If you put that as an answer, you're also good. But check and factor just to make sure that it doesn't cancel. All right. Number 11, difference quotient. 3 steps here. This is a good way to do it, these 3 steps. So I'm going to put f of a. If I put f of a, I'm just putting the a where the x was. It's like that. A plus h, do the same thing. I'm going to put the a plus h where the x was, and just work that out, get 5a plus 5h minus 1. Now I'm going to work the whole thing out, the whole difference quotient. So I'm going to do f of a plus h, which is that. That's going first, 5a plus 5h minus 1, minus f of a, which was this right here. You might want to put a parentheses there, because you got to be careful with that minus sign all over h. So I'm just going to work all that out. And stuff usually cancels, usually works out pretty good. Let's see what happens here. Getting 5a plus 5h minus 1 minus 5a plus 1 all over h. And what happens is my 5a's cancel, my 1's cancel. Leaves me a 5h over h, which is really just 5. Number 12. By the way, that difference quotient has lots of uses in calc, like we talked about this week. We're gonna come back to it several times this year, so make sure you feel pretty good about that one. Number 3. First of all, tell what x cannot equal. X cannot equal 0 or -2, because that'd make the denominator 0. Then we're going to multiply everything up there by the LCD, which is x and x plus 2. My first term, the x's would cancel. That would leave a 3 times x plus 2. My second term, the x plus 2's would cancel. That would leave a 5 and an x. I'm having trouble with my signs today. And on this side over here, don't forget this side. Nothing cancels. So I'm going to multiply that 2 by everything over there. 2x and the x plus 2. All right, so let's just work all this stuff out. Over here, I got 3x plus 6 plus 5x. Over here, I've got a 2x squared plus 4x. Because there's an x squared, I'm moving everything to the right side to see if I can factor it. That's really 8x over there. If I move 8x over here, it becomes minus 8x, which is minus 4x. Move the 6 over, minus 6. Now, the first thing I notice, they're all even, so I'm going to take out a 2. Just drop the 2 out of there, just like that. Factor what you got, which would be x minus 3 and x plus 1. Which means my x's are 3 and -1. Double check and make sure those are okay. As long as they're not those two, 0 and -2, they're good. So there's your 2 solutions, 3 and -1. 2 more, 13. 3x squared equals 5x plus 1. I'm going to take that 5x over and the 1 over. Because there's a square, it means I need to do get everything on the same side. I'm going to try slide divide slide. If I slide, I'm going to come over to the side because I don't think it's going to work. If I slide that 3 over, it becomes a minus 3 there. And there's no factors of 3 that give me 5, which means I cannot factor it. Also, it's not a good one to complete the square because that's odd and there's a number in the front. So we'll go on quadratic formula. X equals -b plus or minus the square root b squared minus 4ac all over 2a. And it's going to work it out the best I can. That gives me 5 plus or minus square root of inside is 25 minus 12, which is 13 over 6. You know what? I can't break that down. Can't cancel anything. That's it. One more, 14. Our favorites, these negative exponents with fractions and stuff inside, all the things. So let's do this first. I'm going to work inside first. Actually, no, I'm not. Because it's a fourth, I'm looking at my exponents inside. Because 4 goes into all those, I'm going to go ahead and raise everything to the 1/4 power. Means I'm going to multiply the exponents. 4 times 8 times negative 1/4 is negative 2. Negative 4 times negative 1/4 is positive 1. I'm just going to write this for now. 16 to the negative 1/4 power. If I do this bottom y, 4/3, I'm going to the side. 4/3 times negative 1/4. What's going to happen? My 4's cancel. I get negative 1/3 there. All right, so here's what's going to happen. The x squared gets flipped. This y to the negative 1/3 gets flipped. It goes up there to join the 1. 1 is really 3/3, so it gives me 4/3 in my numerator. All that leaves is a 16, which is what worries me the most. So I'm going to spend the most time talking about the 16. You got to do two things. First of all, don't forget bottom is a root, top is the power. So I got to take the 4th root of 16, which is 2, by the way. But that still leaves that negative 1. Remember, bottom is root, top is the power. The 2 to the negative 1 means I got to flip it to the top. So it goes right there. And guys, that's it. Probably not as pretty of answer as you're looking for, but that's what it is. All right, so hopefully that helps. Hope you use it as much as you need to. Do great tomorrow. Expecting big things. This one doesn't seem that bad. Hopefully it's not. See you tomorrow.